אז בוקר טוב לכולם, ותודה שהצטרפתם אלינו לאירוע. אנחנו בראש של פורום אבטחת הענן שלנו, בשיתוף Fortinet ו-Exclusive Networks. אנחנו כבר נתחיל עם הרצאתם של עומרי, סגב מויאל וברנטון מוריס, שניהם מחברת פרופרו, כאשר בהרצאה הזו הם ידברו על מעקב אחר יריבים ואיומי פנים בסביבות AWS. בנוסף, נחקור מקרים אמיתיים של פריצות לסביבות AWS ונבחן כיצד תתגלו ומה אנחנו יכולים ללמוד מכך. אנחנו נמשיך עם הרצאתו של מוטי בן עטיה מפורטינט, שבה הוא ידבר על אבטחה מותאמת לענן עם דגש על אבטחת תשתיות ושירותים, והוא יסביר מדוע ככל שמחשוב ענן תופס תאוצה, ארגונים מסתמכים יותר ויותר על שירותים ותשתיות מבוססי ענן. אתם יכולים לשאול שאלות בצ'אט וב-Q&A, והמרצים שלנו יענו לכם על כל שאלה. אני בטוח שתהנו היום, ואני מעביר את המושכות לעומרי וברנטון, שיהיה הרבה בהצלחה.
Right, thank you. So good morning everyone. We are the team from Profero and we'll be speaking today about from the trenches of cloud incidents. So my name is Omri Segev Moyal. I'm the CEO at Profero, and before Profero, I helped founded Minerva Labs.
Hi everyone, I'm Brenton Morris. I'm an incident responder with Profero, and before Profero, I was a DevSecOps engineer at Rome Creative and Westpac NZ.
Very quick introduction to Profero, so you know why we speak about this topic. So we are a company that specializes in incident response. We do just one thing, incident response. It's the only thing the company does. We work globally. As you see, we have Brenton with us from New Zealand, so we work around the sun. We do things like cloud investigation, hybrid, on-prem, insider threats, ransomware, advanced persistent threat, and business email compromise. Actually, right now, we're dealing with one of the most interesting cases that you probably have heard on the news. So the way we constructed this presentation is we wanted to give some real life example of things that happened. We're going to speak about how we detected it, how we investigated, and then in the end, what basically it was. And then in the end, how you can find those things before they reach your environment, or if when they reach your environment, you can enable certain features, etc., so you can better investigate it. So the first case is really interesting, and we wanted to put it first because one of the things we see very often in every AWS environment, especially heavily utilized one, the one with end customer endpoints, and is the utilizations of Salt Stack to run crypto miners. So Brenton, please go ahead.
Yeah, so with this case specifically, we were contacted by a healthcare provider after they'd received a guard duty alert for some crypto mining traffic from an EC2 instance. So we carried out some analysis on this instance and we found some malicious bash files. Here you can see an interesting snippet from one of the bash scripts, which used DNS over HTTPS to hide its domain resolutions to a Tor to web proxy. And the malware actually eventually ended up using the Salt CLI to attempt to spread itself to other machines that it could manage via Salt. So as more organizations move to infrastructure as code, obviously we're going to see this type of attack being used more commonly. So we obviously have to look at mitigations for this. So there's quite a few mitigations you can do, but the basic ones are obviously to secure your automation resources, such as Salt master nodes, Terraform state files, all that kind of stuff in their own AWS accounts. Ensure you've got good access logging and central authentication set up for these. Ensure production changes actually go through a review process before being initiated, such as enforcing pull requests and change reviews before changes can go out to prod. And you want to alert on production changes taking place, because changes like this should be noisy. It shouldn't be quiet. Your engineers should all know that this is happening. And then obviously keep your Salt stack up to date.
If you have any questions, by the way, I'm watching the chat, so feel free to send any questions. We'll have a look at it and hopefully we can answer. If not, we'll come back to you right after the presentation. All right, the next case is very interesting. It was involved in a very diligent insider threat investigation. One of the things that really struck us is in this incident is that when we get into some kind of a cloud breach, and even on-prem, after mostly few days, we can map the intrusion point, the hotspot where certain intrusions occur, and somewhat the timeline and the pathway of access or unauthorized access to certain systems. In this specific case, it really struck us because there was nothing like that. It was all very unique and large hotspot all over the place, different times. There was not very clear explanation of how they access certain systems or how they got the credentials and secrets, etc., to those systems. So what we did, we went into a whole different perspective, and we went to somewhat that is very familiar if you ever dealt with fraud investigations, credit card fraud, etc. We took every single system and we checked how you might possibly get access to it and from what location. And we started to map those, and we're speaking about thousands of systems. And in the end, what really occurred is they all came to HashiCorp Vault. And that's what it became really interesting.
Yeah, so during this incident, we actually started to look through CloudTrail logs while we were doing that ongoing investigation that Omri was talking about. And we found that there was actually a call to a create instance export task API in EC2. And that enables exporting an EC2 instance to a virtual machine image. And from there, we saw that they had actually exported the HashiCorp Vault instance itself into a VMDK onto a public S3 bucket that they could then download the image from. And from there, they obviously ran it in their own lab and pulled down all the secrets that were contained within that image. So then we wanted to look at mitigations for this kind of thing. So obviously, it's not very often that you have an image actually getting exported from an instance. So you want to be alerting on things like export image and create instance export task API calls. You want to restrict who can export these VMs, and also placing high-risk VMs such as secret stores like HashiCorp Vault. That kind of thing should always be in their own restricted AWS account, and ensuring you have adequate monitoring and authentications on these accounts as well.
All right, seems like we have a question, but I can't see it. So if any of the other panelists can read it to me, we're happy to answer it.
Yes, I'll read it to you. Salt stack, what is it?
Cool. Brenton, you want to go?
Yep, so SaltStack, I'm not sure if you're familiar with things like Terraform, but SaltStack is an automation platform for companies that use sort of a DevOps practice. And that allows you to push out updates and run playbooks on multiple machines at once. So if your SaltStack master node gets compromised, obviously they can jump onto other boxes, because that's what sort of orchestrates the update process for pushing out and deploying software throughout your fleet of servers.
Right. Another very common incident we see around clouds, it also related to miners. But the main problem with it that we've seen is not just that it's quite common and pretty easy to solve actually, but that it's causing a lot of damage in the funds and billing of organizations. One organization we've seen over a few $100,000 before it was catched. So this is really heavy. Something really interesting to learn about Amazon that we've seen from, I'm not sure if it's in the official terms of service, but they basically refund you only for your first ever incident. From then on, you probably would be paying, and I don't think they even promised they will refund your first incident. So it's something that really should be taken in consideration. Basically, what you see here is the utilization of GPU dedicated instances for crypto mining. Attackers really like to use that because they don't pay, of course, for the GPU, and they also have a lot of horsepower, so they can use it with shared crypto miner instances, etc., and some mining botnet. Go ahead, Brenton.
Yeah, so this is actually becoming a lot more common. It's quite a common method for monetizing access that you may gain to an AWS account, especially in recent years. We actually saw Tesla fall victim to this back in 2018. This is often the outcome of a wider scale automated attack, and it's very rarely the result of some targeted sort of hands-on keyboard style attack. And because of this, we need to ensure that we have alerting set up on any EC2 instance creation, which is outside of the organization's normal use. So if your org doesn't usually use GPU-enabled EC2 instances, you should know if somebody creates one. And it's also a very good reason to be enabling billing alerts on all of your accounts.
Right. I want to answer another question regarding the previous case. So the question is, I'm guessing that the vault is protected both for its protection and also protecting the key store. How the attackers got over this challenge? So as we said, this was actually an insider threat investigation, and I don't want to get into too much details, but in the end of the day, the person had access to certain key features, including keys, etc., and they were able to decrypt it. So it was basically like creating a backup for them. They had other resources, but this is really good example of something that should have been monitored and would have been caught on way before. Even if it's not an insider threat, maybe hackers can have access to. Now, it doesn't necessarily mean it only work on HashiVault. They could have done it for databases. They could have done it for file servers. They could have done it for other things. So it's just really representing of the cases and what you should be looking for. Now, in your case, hopefully it will never be an insider threat, which are usually very awful and not nice investigations, including, you know, polygraph checks and stuff like that. But it's something that you really should be mindful. And the other question is, do you have an intelligence service that can identify miners running by IP addresses or traffic patterns? So definitely yes. Amazon Guard Duty is doing some really good stuff around that built in. We're happy to dig in with it if we have some time later on. But the Guard Duty is actually doing a pretty good job. And if not, there's some other third-party services, including the coin blocker list, which is freely available. You can download it. All right, so another very interesting case, and we spoke about HashiCorp, but this is another thing that really went public last year. It was a huge incident. Luckily, the main intrusion point and everything was not revealed till now. We are not going to correlate with this specific incident, but we really wanted to bring forward the method that was used here. And basically, the method that we used with Brenton will explain led to a full, huge MongoDB database being exposed and compromised.
Yeah, so during this, we were dealing with an extortionist attacker who was claiming to have a copy of the client's production MongoDB database, which was containing a lot of sensitive customer information. The database in question resided inside a private subnet, and it was only accessible by a few backend API instances. When we went and performed forensics on these instances, we didn't find any evidence that any of these instances had any signs of compromise or any malicious traffic, either in VPC flow logs, HTTP logs, all that kind of stuff. So we were left wondering how that attacker actually gained access to this data. Next slide. So the way they actually gained access was via a snapshot restore. So the org was taking snapshots of their MongoDB cluster every 24 hours, as every good backup strategy should do. And after investigating via CloudTrail logs, we found that the attacker had simply restored a snapshot from the MongoDB cluster into a public subnet and used a security group that they created, which allowed connections from anywhere. Then they connected to this new cluster, pulled down the data, destroyed the cluster they had created, and hid the tracks, and they were done. This happened very quickly, but the data download did take hours. So there was a lot of time that was wasted that the organization could have done and responded to something like this had they known. So mitigations for this kind of attack includes, yes, more alerting. So alerting on things like new security group policies, allowing connections from anywhere, or just any security groups being created at all, because this isn't a very common thing unless it is inside your org, but create the alerting as you see fit. And alerting on new data resources being created, because it's not very common that someone would create a new, document DB cluster inside an AWS account. Usually this is just when somebody is setting up an environment. So you need to know when something like this is happening, even though it could seem like that's not very malicious. And the other thing is to respond quickly to these events, because a quick response time to an alert like this can actually save you when exfiltration is taking place, and it'll rescue your customer data in a situation like this.
The reason we have decided to expose those specific incidents, this one and others, is I think they resemble some kind of methods that the attackers are using. I think it's really different from the usual on-prem investigations and incidents where you have a DMZ and you have another way of accessing. There's things like phishing attacks. In here, we've seen even attacks that from a very simple Lambda function that was vulnerable, they got some level of access, went to EC2s, and were able to compromise all the way to the root account. So those are things that may be more resembling an on-prem investigation just in the cloud, but those kind of things with very minor configuration changes. I don't think we were used to see internal, database completely exposed directly to the internet on old type of on-prem procedures, or someone creating a copy of the ES6 VM and taking it home. Those are things that are very easy to do in the cloud once they have access and they're knowledgeable how to do it. And I think the attackers will be more creative. So one of the things we really want you to take from this presentation is also to think about, like what things can you do as in terms of backups, in terms of connectivity, and those things that the attackers will probably be able to do as well. So all the things that related to segregations and monitoring, etc. Now this comes to another question that someone asked, but basically the question was, and I think it was around the crypto miner incident. In terms of post-security incident, what you can do if a client didn't pay for details, logs and analysis such as GuardDuty, CloudTrail, etc. So if the client didn't pay for such assets or such services, then of course you can also go to the old way of investigating the machine itself. And other locations, you can also look at the billing. It's really interesting because sometimes in the billing graph, you can actually see when the attack started and you can start correlating it. There are some other tools. And of course, there's also a way to contact Amazon support. And some of them, they have those secret logs that you don't really necessarily see or they seen. It's not exactly 100% cooperative all times, depends on, the dollar you pay for Amazon and when is the contract coming up. But in the end of the day, it's something that you can utilize either for your customers or if you are the customer that got breached. All right, and another question is, would encrypting the snapshot with specific KMS key block this attack? So it really depends. On this specific case, I think it should be. Brenton, what do you think about it?
I would say it depends on the permissions on that specific KMS key. If you have the permissions on that key locked down and only certain people can access it, or certain AWS IAM users can access it, then yes. But if it's too open and they gain access to an account which can access that KMS key, then no. So it depends is really the answer.
All right. So now we're basically trying to look at what we can learn from this incident and also the type of things that can help you find those attackers on many different cases, not just the examples we've shown right now.
Yeah, so generally, obviously, first step is to enable CloudTrail in all of your regions. Make sure that you're archiving those logs to an S3 bucket. And for us, a lot of the time, we'll want to go in and make sure Athena is configured because we use a lot of tools that run Athena queries and search through logs looking for bad things in the logs. So make sure your logs are searchable in some way. That could be Athena or Elasticsearch or exporting them somewhere else. Make sure that your asset discovery is on point. You should know where your assets are. You should have a proper change configuration management, that kind of stuff. But for us, we use Scout Suite, the billing panel, AWS config, SSM, all that kind of stuff, that any tools that we can use to find the assets that a customer may have. And then obviously using the tools that are available to you as well. We will go in and we'll review GuardDuty findings, all historical findings. We look for STS token chains with tools like Skywrapper. We check for changes in billing. All of this kind of stuff helps us in the future. And then when investigating CloudTrail, obviously you want to make sure you pivot from what you already know. So looking for certain user agents, IPs, IAM roles, users which have been compromised, all that kind of stuff. Reading CloudTrail logs from start to finish is just not possible. So you need to be pivoting off known information about what, like when you're responding to an alert, look at that alert. What do you know? What can we look for in CloudTrail to get a bigger picture? And then for sort of general things to look for in CloudTrails, obviously changes to automation infrastructure, such as CloudFormation, that kind of thing. Checking for database actions, such as making copies of data, checking for any instance or database exports, checking for network config changes, security group policy modifications. All of that kind of stuff is good to look for. And then some common mistakes when that we've seen when we start working with an organization would be logs being stored incorrectly or in the incorrect directory structure inside an S3 bucket. Just put your logs in the root of the bucket. Don't try and put them in subdirectories. It makes it very hard to actually search through all of them, especially if you've got a multi-account structure set up and you're exporting all your logs from all your accounts into one central bucket. Logs not being searchable before the incident. For example, if Athena isn't configured or you're not exporting your logs, this just eats into time, which could be used for investigating an incident when an incident is taking place. And obviously no incident response training or practice being taken place. So run things like game days. Your engineers should know where to find logs and where to find information they need during an incident. And then obviously also alerting configurations being out of date and not being constantly evaluated and updated, as you should really be changing your alerting, and your alerting should grow as your environment grows. So yeah, so overall recommendations that we have for everyone would be, get the basics right first, knowing your environment, knowing and monitoring where your weak points are, understanding what your usual activity is and building alerting around that. So anything outside of usual should generate an alert. Building relationships with your ops engineers also helps if you're a security person. It's nice to have an open line of communication with ops teams. So if you see an alert pop up, you know who to message and who to talk to find out if this is legitimate or not. Investigating alerts quickly. If you do have a round the world team like we do, it's quite helpful because somebody's always online and something happening in the middle of the night doesn't sit there until the morning. And then enabling all the available logging that you have to you. So data access, logging, VPC flow logs, turn all of that on inside AWS. It's very common that we go into an environment that doesn't have that turned on and we just don't have the information we need to investigate properly. Yeah, and ensuring your logs are searchable and practicing. So game days again.
Yes. So in the end of the day, it's come to a lot of readiness. For example, if a few years ago we've seen on each 4 ransomware cases or normal Trojan or business email compromise cases, we've seen 1 cloud case or similar. Now it's completely vice versa. So we have seen 4 to 5 somewhat cloud-related cases. For example, now there was a huge breach related to code coverage. If you're a code customer and you don't know what I'm speaking about, then go and read about it because you have probably breached. We've seen a lot of those. There's a lot of attackers that are now targeting cloud environments, especially AWS. It's something that they are familiar, I guess, because it's the biggest one, I think. If there's someone from Google here, I'm sorry, but which is something we've seen more and more common. And in the end of the day, it's a bit easier for attackers. If there's a lot of misconfigurations in your cloud, if you don't have enough logs, if you don't follow the alerts and CloudTrail and configurations, then it's something you should probably start doing and practice for it because it's something that happens a lot. It's one of the major target points for attackers. All right, so if there is any other questions, let us know. We're happy to answer. I know we've answered a few of them, throughout the presentation. Our details will be in the next slide. So if you have some more private questions or anything or something comes to your mind, please feel free to contact us, free of charge. Of course, it's not something that we're happy to answer. Apparently, we have 2 questions. So let me just, Stav, can you read them to us? I'm not sure I'm seeing them.
Sure, I'll read them. The first one is, can you add info on STS and Skywrapper?
Sure, sorry. So STS tokens are the temporary tokens that AWS will give you when you run something like assume role. If you run an assume role call as a IAM user, for example, you may use your IAM user's access token, and it will give you a temporary access token which has the same privileges as the role that you're assuming with assume role. What attackers will do a lot of the time is take advantage of the fact that you can't actually see these STS tokens in the Amazon console UI. So you're not gonna, there's no menu that you can just see all the active STS tokens. So STS tokens usually have a very short time to live. So you might call assume role and it might be available for you to use that token for the next hour. But often you might find a role in an AWS account which also allows assume role. So using this, an attacker can call assume role and get given an STS token, and then they set up a cron job that renews that token every hour by just calling assume role with the current token that they have to get a new one. And this effectively gives them a backdoor into your account. Even if you remove the IAM user they may have compromised previous to that to get that initial point of entry, they still have access to the account through an STS token chain that they just keep renewing. So Skywrapper is a pretty good tool. If you look it up on GitHub, it allows you to look for these STS token chains using Athena queries, and it automates the whole process for you.
Right, and the next question we had is, based on your cloud incident response experience, do you provide any incident response readiness checklist to clients? So basically, the question is kind of like in any good question, the answer can come in two parts. So first of all, yes, there is some checklist. There's some also from our friends here in Israel Clouds and Moshe Freber and others that have really good checklists for clouds. But in the end of the day, what we learn is that although people use the same services in AWS, they're not really using them the same way. And when it comes to incident response, one of the things that, and especially incident response readiness, is the thing you really need to evaluate each and different setup and settings individually. So we can give you some of the key bullets you should look for, but for actual readiness, it's something that needs to be much more customized. We don't believe there is any, fresh off-the-shelf product or similar that can then magically be your IR readiness or a checklist. It's something that you need to take as examples maybe, and then move them to your organization. And of course, we're happy to assist in any specific cases. You can contact both me and Brenton on Twitter. Sorry for my voice. You can have, or directly in our emails, and we'll be happy to assist and help in any case or any questions. All right, so we'd like to thank you for your time. It's most of you are in Israel, I bet, so it's quite early in the morning. And I'm moving the stage to Moti Ben Atiyah from Fortinet.